Hello everyone, this is Shah Dhruv Rajendrabhai, and today we are going to tell you how artificial intelligence have revolutionized stock trading. First, I will introduce you how AI is being used in stock trading and what are its main benefits in stock trading. Next, I will explain you how portfolios are formed using different models and techniques of AI. Next, my teammates will explain you about the use of KNN and SVD to give personalized recommendations to the traders. After this, we will show you how ANN plays a major role in the stock trading. At last, we will explain you how NLP also has a role in the stock trading. This is our team. In the present time, there are a huge number of efficient techniques which are quite useful in building a high profit, low risk portfolios. This even helps the people who knows quite less about stocks but can make profits in the stock market. Stock markets depends on too many factors and this makes it quite difficult for normal humans to trade in stock market. But machine learning methods takes in large data sets with too many dependencies and predict stock prices with much high accuracies and becomes a very important tool in stock trading. Many times some news or some social media things highly affect stock markets. This information can be translated by NLP, that is natural language processing, and can be used for buying and selling stocks of different companies and observing the trends of the company's shares. The term automated trading completely dependent on artificial intelligence. There are many strategies developed which does trading automatically depending on the market trends and conditions and buys and withdraws stocks from market as and when required. And one of the main feature of AI is its capacity. It can execute millions of transactions at a particular instant and this makes stock trading quite easier since many stock exchanges of the world need to perform huge number of exchanges in a second. So, what is a portfolio? A portfolio is a collection of financial investments like stocks, bonds, commodities, cash, and cash equivalents, including closed end funds and exchange traded funds. Portfolio construction has been a long existing problem in finance where there are debates on the objectives for investors with different financial needs. Portfolio optimizations can be formulated as an reinforcement learning problem where the reward indicates the financial goal. Recent advances have enabled the seamless integration of deep learning and reinforcement learning for practical solutions, which expands the universe of solvable multi-period decision-making problems. Alpha portfolio is one of the models used to build a portfolio. It have three objective functions and four objective features. The model consists of three parts: a sequence representation extraction model SREM, a cross asset attention network CAN, and a portfolio generator. SREM feeds the multivariate time series of each stock to a transformer encoder with shared universal parameters. It maps the sequential input into a high dimensional latent space and retrieves the underlying embeddings. Next, CAN module applies cross attention on SREM and embeddings to capture the interactions between different stocks. CAN generates a scalar winner score for each stock. Finally, the portfolio generator applies a softmax operator to obtain the allocation proportions that are within 0, 1 and -1, 0 for long and short positions respectively. The return for the following month is calculated using the allocation proportion vector and each stock's return. Next, I will pass on to my teammate Pranav Mehrotra.
Thanks, Dhruv. Hello, I'm Pranav Mehrotra, 20 CS 185. Today, I'll be presenting about using AI techniques like k-nearest neighbors and singular value decomposition to give personalized recommendations to the traders. We will try to give personalized ratings to each of the stocks to help the traders find stocks with greater potential of higher returns. Both of the techniques used are based on collaborative filtering, which is one of the most popular techniques used to build recommender systems. It works on the assumption that users with similar preferences in the past are more likely to have similar interest in the future. Now, we first start with data cleaning and pre-processing. We first divide the traders into three different categories: short term, medium term, and long term traders, as they tend to have different trading strategies. Like long term traders are generally less open to investing in small cap stocks, as these stocks tend to carry more risk and tend to invest in large cap stocks that entail less risk. Therefore, in this study, if a trader holds a stock for less than 3 months on average, we define them as short-term trader. We consider them a medium-term trader if they hold a stock for more than 3 months but less than 1 year on average, and a long-term trader otherwise. Furthermore, we also want to provide profitable recommendations to the users. So, assuming that the users who earn profits from their investments traded in stocks that have good returns, we should build our recommender system using only these group of users. Hence, we focus on those traders who have earned a positive average rate of return. Also, for the group of users that have negative rates of returns, it might be better to take a non-personalized approach instead, where the most popular stocks that the users who have benefited from should be recommended, with the hope that they will get better rates of return. Coming to data clustering, the datasets of stock markets are huge, as hundreds or even thousands of transactions are taken every minute, and the computation grows exponentially as the number of users and items in our data increases. This affects the scalability of our recommender system. Hence, to reduce the volume of data points, we seek trends. Generally, in stock trading datasets, the data points are dense in some regions and sparse in others. Therefore, we can cluster the users based on their total spending on each stock before building a recommender system for each cluster. Agglomerative hierarchical clustering is a popular cluster method that aims to achieve maximum within cluster similarity and minimum between cluster similarity by presenting the data in a tree structure called dendrograms. Agglomerative hierarchical clustering performs a bottom-up approach where each pair of clusters is combined in each iteration until one big single cluster is formed. These are the dendrograms of an example dataset with three different types of traders, namely short, medium, and long-term traders. After data clustering and pre-processing, we now start to apply our models onto the data. First, we will use k-nearest neighbors to build a recommender system to assign a personalized rating to the stocks. We will first need to preference of one of the stocks, another for another trader in the training data. Therefore, we estimate every user's I and rating of the stock J, where the numerator represents the total quantity of the stock J bought by the user I in his K transaction, and the denominator is the total quantity of all the stocks that the user I has bought. The KNN based approach is a non-parametric lazy learning algorithm that trains the dataset whenever a recommendation is needed. The KNN approach aims to find the K most similar users using the cosine similarity. And how well the model performs depend on finding the most optimal value of K. Too large a value would result in being computationally expensive and underfitting, thus leading to poor prediction performance. Too small a value for K leads to overfitting and poor performance on an unseen data. Hence, to determine the optimal value of K, we plot the error rates for a given range and choose the optimum K to be the one with the least error rate. After specifying K, consequently, we use their weighted average to calculate the predicted rating for target user I on the item J. We next provide the recommendation based on the top n items with the highest predicted ratings for each user. Now we move on to singular value decomposition model. It is a dimension reduction matrix factorization technique. SVD aims to extract latent variables to decompose the user-item interaction matrix into vectors of user and item factors separately. The predicted rating that user I will give item j is then calculated as a dot product of the corresponding user and item feature vectors. And to estimate the unknowns, we solve the optimization problem. To solve this optimization problem, we use the stochastic gradient descent by recursively solving these three equations. And after obtaining Qj and Pi, we can calculate the ratings and recommend the top n items with the highest predicted ratings for each user. So this was my part. Thank you. And now my teammate Anand will take over from here.
Thank you, Pranav. Greetings. My name is Anand Manojkumar Parikh, roll number 20CS10007. Today, I will explore an application of artificial neural networks in stock trading. Firstly, let us have a brief introduction to artificial neural networks, or in short, ANNs. ANNs are a very popular class of machine learning models that consist of several processing units called nodes, which are connected through a network of connections. The overall structure of the neural network looks like this. There are mainly three kinds of layers. There is one input layer that receives inputs directly from the data that we have trained. There are multiple or possibly none hidden layers. The first hidden layer receives input from the output of the input layer, and so on. There is also one output layer. Each node in the output layer, in this case there is only one, receives input from the last hidden layer. Note that each unit in the output layer has only one output. This is the final information that ultimately advises us whether or not to take some action. The internal structure of each node looks like this. The inputs x1 up to xn are first converted to a single value by an adder that does this. It multiplies each wi with xi and finds the summation of wi xi. Now this value is fed into a decider, which for our purposes is a sigmoid unit, since it is continuous and differentiable everywhere and best mimics a signum function. The output of the sigmoid unit is the final output of this node. Now the question remains as to how we can train these weights. We can use multiple solvers and methods for this purpose, but in our example, we use a popular combination, that is the stochastic gradient descent solver and the backpropagation algorithm. The exact mathematical details of the SGD solver and backpropagation algorithm are not discussed here, but in brief, they can be seen like this. So in the backpropagation algorithm, we first begin by assigning random weights to all the small random values to all the weights. The algorithm then makes multiple iterations over the training examples, and the solver tries to improve the weights slightly each time in an attempt to make the ANN's output better fit the actual target values of the data. From this figure, we can see that the nodes whose error is directly available is the output layer because their output can directly be compared with the target values of the data. So we first compute the error values for these output layers, for the nodes in the output layer, and this information is then percolated backward through the net. Hence the name backpropagation. Let us take a look at the SGD solver that calculates the amount of change in weights in each iteration. So we can visualize it as trying to descend down this error surface in an attempt to reach the global minima. So this is the error function with respect to the weight values. Now it might seem dangerous to get stuck at a local minima. Here there is no local minima, only the global minima. But in practice, the SGD solver works actually quite well. Now let us look at the actual model that helps us to choose amongst the actions buy, sell, or hold for some given stock information. We first extract some important dimensions that can be used as inputs to our ANN. One of them is RSI, which shows us the historical strength or weakness of stock prices and also compares the losses and gains in a specified period of time. The moving average, convergence or divergence, is a technical indicator that illustrates the trend of the stock prices. The Williams percentage R is a momentum-based indicator that shows the overbought and oversold conditions for stock prices. Now, how or why we extract exactly this information is based on a lot of observation and experimentation, along with dimensionality reduction techniques, which is another popular field of machine learning. And this is what our final model looks like. It is a very simple and small three-layer feed-forward neural net that takes in the three parameters that we have computed from the available data. It can be trained using the backpropagation algorithm that we mentioned before. And the output is either of three classes: buy, sell, or hold. The interpretation of the output is very simple. Whichever is 1 or highest is the optimal action, and the ones which are 0 or lowest are not. So the model directly instructs us what action to take for a particular stock for maximum benefits. So the entire process of decision making has been automated by the neural network given the training data. Finally, let us take a brief look at the advantages and disadvantages of using ANNs for stock trading. The advantages are that ANNs have the power to learn very complex non-linear target functions having a variety of inputs interconnected in a complicated way. Historically, ANNs have shown very promising results and accuracies ranging from 70 to 80% when outputting the optimal action. We can use the same models for regression as well as classification by making small tweaks. So not only we can make decisions, but also predict the future prices of stocks. On the other hand, there are a few disadvantages. The training times of ANNs are generally large, but once trained, they can make decisions quickly. The explainability of ANNs to humans is very low. This means that if we choose to use ANNs, we must follow the directives that it gives us without having much insight or intuition as to why those outcomes have been generated. Also, if the number of hidden layers or the number of epochs, that is the number of iterations of the backpropagation algorithm we run, is designed poorly, if any of them is designed poorly, we might encounter the classic problem of overfitting the data or some other problems that lead to higher chances of error. Thank you very much. Divyansh will take over from here.
Thank you, Anand. Greetings. My name is Divyansh Vijayvergia and I'll be talking about application of natural language processing in stock trading. First, I'll talk about motivation for using NLP in stock market. As we know, stock market is very dynamic market which changes in matter of seconds and is highly influenced by data and information from various sources. One example of it can be seen when Elon Musk's tweet dropped the value of Bitcoin by $365 billion in a single day. This shows the importance of data and information. In such a scenario where there is tremendous amount of data flow on daily basis, it is humanly impossible to stay up to date with all the information and changes in the stock market. Here NLP comes to rescue to automate this process. I'll be talking about one such model based on natural language processing which classifies the stock movement based on the impact of each stock related news. The backbone of this model is the idea of semantic role labeling. Semantic role labeling is used for finding semantic relationship between different parts of sentence and classifying them into respective roles. A successful run of SRL converts the sentence into a set of predicates and prepositions. The model has other interesting features such as inclusion of various stock factors along with stock related news and consideration of the fact that the distribution underlying the training dataset and the test dataset could be quite different. Both of these features were not considered in any of the previous NLP models. Also, the model uses a self-supervised learner to improve generalization of the NLP classifier well beyond the training dataset. Now, the working of the model can be divided into different parts. First, the dataset is created and then the semantic role labeling is used to create compact representation of the stock specific news. Then a self-supervised model is implemented and lastly NLP classifier is trained. We will look into each part in more detail. First, let's look at dataset creation. A dataset of Chinese stock market is created which includes stock related news along with various stock factors. This dataset is much more comprehensive as compared to any previously created dataset as it includes minute level information about each event along with 24 stock factors for stocks of each company. The dataset is divided into two parts. First is in distribution split which contains data collected from July 2018 to December 2020. The in-distribution split is further divided into 80% training data, 10% validation data, and 10% test data. The other split is out-of-distribution split, which contains data collected between January 2021 to November 2021. This out-of-distribution split is used for testing the model on the data whose distribution is different from the training data. Now let's see next part of the model, which is semantic role labeling. First, the semantic roles are identified in a sentence as shown in the following example. Here, the semantic roles for the verb be, proto-agent A0, and proto-patient A1 are identified in the sentence. Each sentence is then processed by a pre-trained language model which converts the sentence into a set of embeddings, and these embeddings are essentially vectors. The indices of embeddings corresponding to each V, A0 and A1 of the sentence are stored in italic V, A0 and A1 respectively. Then the SRLP element is calculated by taking weighted average of the corresponding embeddings. Collection of all such SRLP elements for all the sentences in a piece of news along with the stock vectors are stored in a matrix. Now let's talk about another main feature of the model, which is self-supervised learner. Apart from regular supervised classification model, a self-supervised learner is proposed which uses the output of SRLP phase and helps in generalizing NLP classifier beyond the training dataset. The high-level working of the learner involves masking a SRL element in the output matrix of the SRLP phase. Masking is done simply by replacing the element in the matrix by a zero vector. The goal of the self-supervised learner is to identify the masked SRL element from a given set of embeddings. It is hypothesized that in the process the learner will have to reason about the unmasked elements, which will increase the overall generalizing power of the model. The working of the model is summarized in the following figure, the individual parts of which are already discussed in detail. The right hand side is the supervised module, which contains the SRLP and the classification model training submodule, and on the left hand side is the self-supervised module. Now let's see the experimental result of this model in comparison to existing models. Experiments are conducted for two splits of the dataset, the in-distribution split and the out-of-distribution split. The prediction results of the model are fed to the proposed trading strategy to analyze the profitability through back testing on the real-world stock data. It can be clearly seen that this model outperforms other existing models. With this, I end my discussion on NLP model. So we saw how artificial intelligence can help in analyzing forecast markets with greater accuracy and efficiency, which mitigates risk and provides higher returns. In this presentation, we discussed some of the ways in which artificial intelligence can be used in stock market, ranging from portfolio creation to using single value decomposition and artificial neural networks in making accurate predictions. And lastly, we discussed about a natural language processing based classification model. But artificial intelligence is fast growing field and its possible application in the field of stock market are limitless. With these remarks, we conclude our presentation. Thank you.